All right, welcome. Today we're diving into something pretty cool, something that powers basically our entire digital world. We're talking about the invisible conversations that happen when different applications need to talk to each other across a network. It's like a digital glue that holds everything together, and we're going to take a look at how it works. So, here's the big question, right? How do programs running on totally separate machines, maybe even on opposite sides of the planet, actually work together? I mean, think about it. When you book a flight online, your browser is talking to an airline server. That server then has to talk to a payment processor server, which could be anywhere. These are completely different pieces of software on different computers. How on earth do they coordinate so perfectly?
And the answer, believe it or not, comes down to this thing called middleware. You can think of it as this special software layer that acts like a universal translator. It just sits right in between all the different applications and their operating systems. What it does is create this one, single, unified service layer that spans the entire network. It hides all the messy, complicated details and just lets these separate programs talk to each other like they're sitting right next to each other on the same machine. It's pretty clever stuff.
Okay, so here's what we've got on tap. We're going to explore the three main patterns for this digital glue: the direct call, the object call, and what's called the mailbox model. Then we'll finish up by figuring out how you choose the right style for what you're trying to do. Right, so let's get into it. Middleware is the big idea, but it's definitely not a one-size-fits-all kind of deal. There are actually three main styles, or patterns, that applications use to talk to each other, and you'll see each one has a totally different vibe. This table gives us a really nice high-level snapshot of what we're talking about. You've got RPC and RMI on one side. We call those tightly coupled. Think of it like a direct phone call. You and the other person have to be on the line at the same time for the conversation to happen. Then you have message-based systems, or MOM, which are loosely coupled. This is much more like a postal service. You can drop a letter in the mail without worrying if the other person is home to receive it right that second. Big difference. Okay, let's kick things off with our first pattern, which is probably the most intuitive one: the remote procedure call, or RPC for short. The whole game here is to make a call to another computer look and feel exactly like you're calling something right on your own machine. So the key word here is transparency. An RPC system is designed to completely hide the fact that there's even a network involved. I mean, the whole goal is for a developer to write a piece of code like calculate A, B, and not have to think for a second about whether that calculate function is running locally or on a server in a data center 1,000 miles away. It should just work.
And if we go back to our analogy, RPC really is that direct phone call. The client application basically dials up the server, asks it to do something, and then it just waits. It waits right there on the line for an answer. We call this a synchronous or blocking conversation. Now, this is awesome for getting an immediate response, but you can probably see the downside, right? If the server is slow or busy, the client is just stuck there, waiting. That can cause some serious bottlenecks.
So you might be wondering, how does this magic actually happen? Well, the secret sauce is these little helper components called stubs. Let's walk through it. First, your client program calls what looks like a normal local function, but it's actually the client stub. That stub's job is to pack up all the parameters into a message. This is a process we call marshalling, and then it tells the operating system to send it over to the server. On the other end, the server's OS hands that message to the server stub. That stub unpacks it. You guessed it, that's unmarshalling, and then it calls the actual procedure on the server. Once that's done, the whole thing just happens in reverse to send the result back. It's this really well-choreographed dance, all just to make a remote call feel local. All right, on to our second pattern. Now we're going to see how this idea evolves a bit. We're stepping into the world of objects with something called remote method invocation, or RMI. You can pretty much think of it as RPC's more modern, object-oriented cousin. Yeah, this really gets straight to the point. With RPC, you're calling these standalone procedures. But with RMI, you're invoking methods on remote objects. It sounds like a small change, but it's a really powerful shift in how you think about things. And you'll notice the terminology is a little different. Instead of stubs, RMI uses proxies on the client side and skeletons on the server side. But honestly, they do pretty much the same job. This picture gives you a perfect idea of how RMI works. The client isn't talking directly to that remote object way over on the server. Nope, it's talking to a local proxy object. And this proxy looks and feels exactly like the real remote object. The proxy is the one that handles all the messy network stuff, sending the call over to the skeleton on the server. The skeleton then takes that call and passes it along to the actual object. Now, this is where RMI gets really interesting. It's in how it handles the data you send with the call. So for simple things like numbers, it just passes a copy. We call that pass by value. But check this out. If you pass another remote object, RMI is smart. It doesn't copy the whole thing. It just passes a reference, like a pointer to it. And for just a regular local object, it can actually make a complete copy of it, freeze its state, and send that whole thing across the network. That cool process is called serialization. Okay, time to shift gears completely. For our third and final pattern, we're looking at message-oriented middleware, or MOM. And if RPC and RMI were like a live phone call, MOM is totally different. It's much more like sending a letter through the mail. The absolute key to understanding MOM is the message queue. This is the heart of the whole thing. Instead of making a direct connection, the sender, which we call a producer, just drops a message into a queue. And then, sometime later, whenever it's ready, the receiver, or consumer, comes along and picks that message up from the queue. And that's why the postal service analogy works so well. The sender doesn't have to wait around to see if the receiver is available. It just trusts the postal service, in this case the middleware, to hang on to that message and make sure it gets delivered, eventually. You can imagine this gives you an incredible amount of flexibility and makes your system much more resilient. And this leads to what I like to call the two superpowers of MOM: space and time decoupling. Space decoupling means the sender doesn't need to know who the receiver is or even where it is. It just sends a message to a topic, like new orders, and has no idea who's going to read it. Then you have time decoupling. This means the sender and receiver don't have to be running at the same time. You could post an order even if the order processing system is down for maintenance. No problem. It'll just grab it from the queue when it comes back online. And even within this MOM world, you've got choices. Asynchronous messaging is the classic send it and forget it style. But you can also do synchronous messaging, where the sender actually waits for a confirmation that the message made it to the queue. And you also have a choice between transient messages, which are super fast but might get lost if something goes wrong, and persistent messages, which the middleware safely stores on a disk to guarantee they will never, ever disappear. Okay, we've made it through the three main patterns. So the big question is, how do you choose which one to use? Let's bring it all together and compare them side by side. It'll make it really clear when you'd want to use each style. This table right here, this is really the key takeaway. It's pretty simple when you boil it down. You're going to use RPC or RMI, our phone call models, when you have that tight back-and-forth conversation, where you absolutely need an immediate answer. And you're going to use MOM, our postal service, when what you really need is reliability and flexibility, when all the different parts of your system need to work on their own without being tied together in space or time. And this quote just hits the nail on the head. It's not about which one is best. There is no single best answer. It's all about what kind of conversation your applications need to have. Is it a quick back-and-forth chat, or is it more like sending a package that has to get there no matter what and can be picked up later? The right tool always depends on the job. So that leaves us with one last thing to think about. Now that you know these patterns, start looking for them. As you use all the complex systems around you, e-commerce sites, social media, you name it, you can now start to see these patterns playing out everywhere. The direct calls, the object interactions, the messages flying back and forth, they really are the invisible conversations that power our entire digital world.